On this third video, we're just gonna verify that we still have at least 100 milliseconds of firing signal when we shut down the 120. So what Tony's going to do is he's gonna turn off the 120 here, and the 120 will de-energize this relay. It will take away this 24 volts DC command, and because it's not gonna be there, then the unit will crowbar, but at the same time all the energy will dissipate. But we have to make sure that we have at least 100 milliseconds before anything happens, because we need at least 100 milliseconds to satisfy this customer to verify that the unit will crowbar. So Tony's got 120 out of the power strip going through the board, and he's going to disconnect the power supply, which this one comes down to, right, Tony? Yeah, which, you know, I mean, eventually it will die, but more importantly, here we're just showing that this 24, it's the relay, it's closed, and we'll come back and take a look at that relay. So we're over here. We have the 24 volts DC. We're going to look at the crowbar output when we fire, and we're ready to do that. Go ahead, Tony. All right. So Tony has lost the power. The relay kills the 24 immediately. It doesn't allow for that power supply to slowly decay. It's just the relay open up its contactors. Yet the unit has enough energy to fire for at least this much, which is 20 milliseconds. 1, 2, 3, 4, 5, 6, 7, 140 milliseconds. All right. This is oh, and now the other thing that we wanted to point out here is the relay. The relay now at this point, it's 24, but now it's closed, and it will not act, because although you have the 24 volts for the relay, the signal driving the LED, it's dead now. So let's go ahead and try it out again, Tony. Bring it on again. So it's on. So now let's see what happens to the CV status relay when we lose 120. So we see that it didn't do anything because the signal that drives that LED coming out of this board doesn't have the energy to do it. So this is the end of this video.